Okay, so word problems, we have kind of 4 types. We're going to go through them. So this first type I would call a chemical solution. Okay, so this is what is going on. You have like a container. Okay, so here's what we have. We have a solution of 20 liters, and it has antifreeze and water in it. So the solution means that this liquid in here is a mix. There's some kind of chemical and water in there, and it's 40% strong right now. So if 40% is chemical, how much chemical is in there? 40% of 20 liters? 40% of 20 liters equals, do you know how to do that math? How do you do a percent of something? What would you type? You would do 0.4. 40% of 20 is 8. Okay, so 8 liters of chemical in the whole mix. And what we're going to do is we want to increase the strength to 60%. So we're going to add more chemical in there. And the chemical we're talking about antifreeze. Okay, so I'm going to give you the strategy for these questions. Okay, so you're going to do this, the chemical at the start plus the chemical that you add tells me all the chemical in there, divided by the total fluid plus the add. So does it make sense? The chemical divided by the fluid is how strong something is. Okay, and this gets used for everyday life, like inside these bottles, like disinfectant. Okay, it's measured how much chemical per water, tells you the percent strength that it would be. Okay, so here we go. How much chemical did I start with? 8. How much chemical did I add? That's the thing that's the question mark, right? So I'm going to call it an A variable, divided by how much fluid did I start with? 20. How much fluid did I add? I added some kind of chemical, which is some kind of fluid adding. Okay, it doesn't matter if it's water or chemical, that all contributes to the fluid inside there. Equals, and I want to end up with 60% at the end. So 60% could be written in a few different ways. How could you write 60% in math? Give me one option.
0.6.
You could do 0.6. Is there another option for 60%? Maybe a fraction option? 60 over 100. What did you say? 3/5? 3/5. Okay. I'm going to go with 60 over 100. Just because then I don't have to think about anything. I just do something over 100, something over 100, whatever percent it might be. There you go. That's the hard part. Now you got this. What do you do from yesterday? This is all yesterday's stuff. Should I, option 1, cross multiply, or should I common denominator drop? I should cross multiply. Okay, so there's my cross multiplying. I distributed what I needed to when I did that. And then I'm going to isolate algebra. So collect x's together, collect a's together here. So I'm going to go minus 60a. Okay, isolate, move, divide, and I get 10 liters of antifreeze that I'm going to add to this. So I'm going to think about my answer. At the very end, I would have 18 liters of the chemical, and I have 30 liters of all fluid. So if there was 18 of chemical divided by 30 of the entire fluid, look at that. 0.6, right? 60%. Okay, the only other version of this question is sometimes I might just start the jug with water. So there might not be any chemical to start with at all. It might just be pure water and then add chemical. So that's the foundation. But sometimes the only difference is sometimes you start with chemical already in there and you're adding more, and sometimes you start with just water and then start adding chemical. So in that case, that's just a 0, okay? Okay, next question is a time rate question. So I want you to give me a little T-chart here. Time and rate. And then we have Jeremy and we have Carl. Okay, so what is the difference between a time and a rate? A time is just how much time has elapsed that you've been working for. And a rate is a specific amount of time what it takes for you to do the whole job. Okay? So does that make sense? So I might say, I can paint this room, this entire room, in 3 hours. 3 hours is a rate because that's me doing a whole job. Okay? You might walk in and I've only been painting for 1 hour. That's a time. Okay? Does that kind of make sense in your head? Okay, so it takes Jeremy 20 minutes to push mow the yard. So is that a time of him working or is that a rate of him doing a whole job? That's a rate. If Carl helps, then it would take them 12 minutes. Is that a time of working or is that somebody's rate to do a job? That's a time. That's not a rate, okay, that's just a time that they work for. So 12 is the time, and they both did it for 12. So if Carl were to work alone, how long would it take? So that means we're trying to figure out Carl's rate, because if alone, how long to do a whole job? Okay. So Jeremy does 12/20ths of the job. That's the portion that he does. And Carl does 12/8ths of the job. That's the portion that Carl does. So right, you can see them both mowing the lawn together. And this is a proportion, this is a portion. And together, they complete the entire yard. So this is the portion that he does, the portion he does, and together they're doing the whole thing. Okay, so does that make sense? I told you my rate was painting this room in 3 hours. So if 1 hour has passed by, what's the portion of the room I've painted? 1/3 of it, right? If 1 hour has passed and it takes me 3 hours to paint, I've now done 1/3 of the job, right? Okay, so time over rate is the job done. Time over rate equals job done. It's kind of what I'm doing. Okay, that's the hard part. Now the rest is all you. What do you do from yesterday? Should I cross multiply or common denominator it? I should common denominator it. Okay, what do I need as a denominator that's going to work for all three things? 20K. 20K. Okay, here we go. Look at the first fraction, the bottom, the new bottom. What happened? A K. So I'd have to multiply by a K. On to the second fraction, the bottom was a K. Now it's a 20K. So what happened? Times by 20. So 240. Over here, the bottom was a 1, and now it's a 20K. So what happened? 20K over 20K, right? Whatever this is, it needs to be same over same because it's a 1. This is where you say if the bottoms are the same, what can I conclude in math? Tops are the same. And now you isolate. So move the K and divide. So what does it mean? If Carl is doing this yard all by himself without Jeremy, it would take 30 minutes to do the yard. That's what? Embarrassing.
I don't know how big the yard is.
Don't know how big. It takes me like 3 hours to do my yard. Riding a lawnmower.
And you don't make fun of babies for not being able to mow the lawn in half an hour.
Yeah.
Jeremy's 30.
What if he's in a wheelchair, huh?
Okay, this is another version of a time rate question. You're going to use 3 hoses. You're going to use 3 hoses, and you're trying to fill up a pool. I guess we're going to assume all the fun things like the water pressure is the same, and I know, eh? Okay. Yes. If you were going to only use the first hose, it would take 10 hours to fill up your pool. So would you say 10 is a time of working or a rate of a whole job? Rate. If you were to just use hose number 2, it would take 12 hours. Rate. If you were going to just use third hose, it would take 18. So that's a rate. So now, if you're going to use all 3 together, how long would it take? Well, that whatever that time is the same time from them all, right? Because that's them all, job done, and the time would stop. So we'll call the time X. And it is the same time because it's the pool is full and we stop, and whatever time that would be for them all. Okay, it's the same thing as last time. The first hose will do X tenths of the job, adding to the second hose, which does X twelfths of the job, and the third does X 18ths of the job, and all together the 3 hoses working would complete one whole job. So I always remember in the past, this question always made me giggle because instead of using 1, 2, and 3, I used A, B, and C. Do you see what would be funny if I used A, B, and C? This used to be my question. Using hose A. Got it? That made me giggle too much, so I had to change the question. Okay. I'm picking a common denominator.
Why do you equal 1?
Because these are all the jobs of the 3 of them, and then when all 3 of them are working with jobs, they complete the whole job. The whole job is the 1. These fractions are just the portion of the pool number 1 fills up. There's a portion that pool 2 gets filled, 3, and then together they all fill the 1 pool, right? Okay, who's getting me a number that's going to work? And it doesn't have to even be the lowest. I just need, in this case, I just need a number to work for all of them.
2,160.
2,160. You're picking, okay. I'm trusting that it works. It's divisible.
Multiply them all together.
Yep. There's definitely one lower, but that's fine. 180 works. Doesn't matter. You can use 180 in common or this. So every other time I'm like, you have to use the lowest common one. This will be okay if you don't.
All 1
No, just for this type one. Okay. So I have to times 10 by what to change it there? 216. 12 would have to get times by what? Pick such a big number here. Now I got 180. So 180x. And then 18 times, is it 120? So 18 times 120 would get that. So then, and then this is easy because writing 1 is just the same thing over the same thing, right? Okay, mathematically, if the bottoms are the same, well, the tops have to be the same. So I'm going to do this at the same time if you're okay with it. I'm going to put those x's all together. Does my answer make sense? Would it be reasonable that now if they're all going at the same time, now it's going to be 4 and a bit hours to fill up that pool? Okay, last type is a physics question. Velocity formula. Who's my physics formula people here? Distance divided by time. What if I do distance? How do you rearrange that to be distance? Velocity times time. And time would be distance divided by velocity. Okay, so that's the 3 versions of physics. Okay, a boat goes upstream in the same time that it goes downstream. So here's what we're going to do. We're going to go time up is going to equal the time down. And we're going to now pick this physics formula for time.
Speed.
Speed.
Speed with direction.
Yeah. speed. Like in your car, you go 100 kilometers per hour. That's a velocity.
Just velocity of
Yeah.
the direction to that.
Yeah. Okay. Here we go. So I'm gonna need the distance on the top. So up. What's the distance that we go upstream? 9. On the other side, what's the distance of going the downstream? 11. We do not know the speed of the boat. So can we call it B for boat speed? The speed of the boat. But here's the thing. We have a current in a river, 3 miles an hour. So when you go upstream, does that current add to your speed or take away from your speed? Subtracts. It makes you slower when you're going upstream. And then when you go downstream, it would make you faster. Okay, that's it. What do you do yesterday? Are you picking to cross multiply strategy? Okay, cross multiplying, isolation, group your B's together, move your numbers, divide. Does your answer make sense? Do you notice how I always ask myself that? 30 miles per hour, reasonable answer for a boat speed, right? So I'm gonna give you a hint on what are the two variations for this. So this time I was figuring out the boat speed. I could also give you the boat speed and you have to figure out the water speed. That's another thing I could do. But you always have to do the boat plus or minus the water. Don't do the water speed plus or minus the boat speed. That doesn't make sense, right? So you always are doing it boat plus or minus the water. I also might do what? An airplane plus or minus the wind. Same thing, right? Okay, do not mix that up because if you do the water speed subtract the boat speed, that's weird because then it's negative, right? Probably. Okay. So that being said, I think on a test one year I had figuring out the speed of the water and I had answers that were things like negative. Does that make sense to have a negative speed of something? No. So something went wrong. I also had that your water was going like 140 miles per hour. Is that probably a realistic answer?
Probably not.
Unless there's like a hurricane or something, but you're probably not boating, hopefully, if there's a hurricane. So again, does your answer make sense? If there was a negative speed, you probably have to go back and figure out where you went wrong.